Good morning, Mr. Stat Sensei, Mr. Spensei, and this is a test review, and this is a paired hypothesis, and it's going back to what we did in our warm-up. Basically, it's saying determine at the zero point zero 0.01 significance level whether or not the medication is effective in lowering systolic blood pressure. So right there, the fact that they're talking about the level of significance, they're telling us our alpha level is 0.01. Well, we probably need to go back and look at what the scenario said. So it said the scenario was more than 100 million adults in the United States. That sounds like a population may have high blood pressure. A study investigates the effect of a new antihypertensive medication on systolic blood pressure. Researchers randomly selected 10 patients, as I'm glad they said random. All right, so we know that because right there, that's our very first part of our conditions. And we know that our sample size is 10, and measured the systolic blood pressure before starting medication and then again after. The fact that they were measured twice tells me this was paired. All right. The researchers calculate the difference in the blood pressure before minus after. So this tells me the order we need to subtract in. And the dot plot of the differences indicated that the mean of the differences was normally distributed. So condition number 3 is met by normality. So we need to go ahead and determine the significance level. We do that by running a hypothesis test for paired. So the formula for a paired is T equals X bar D minus mu D SD divided by square root of N. And yes, you have to have the D's on there. If you have this, we're going to assume that you're running just a plain old one sample. While they're very similar, this one has D's because it's paired, so I don't want to see that formula. I need to see it with the D's on there. All right, so like in the warm-up, I went ahead and entered all the information for the paired data. Here it is into my calculator in the stat edit. So there it is in L1 and L2. And then I went up to top of L3 and I go blue 1 minus blue 2 to get L1 minus L2. And there's the difference 150 minus 133, 160 minus 142. Stat calc, one variable statistics. I need to make sure my list is on L3. If it's not, blue 3. And there's my sample mean, there's my sample standard deviation, and there's my sample size. Please remember, whenever you're running a paired, this is only true for a paired, but whenever you're running a paired, this mean will always be 0. So this is 0 milligrams. Oh, excuse me. It's not milligrams. What is it? Well, it doesn't say. All right. But this is our pressure. All right. Okay. And this is 15.1. And there's 10, and there's our sample standard deviation. And once again, we're running a one sample paired t-test. The key word that you need to have is paired. All right, that's the key word. Um, so please make sure you include paired, otherwise it's not going to be correct. You're saying it's one sample and it's really a paired, and that's a little bit different. All right, all hypothesis tests are centered on the population mean, so our claim is 0. We have a X bar of 15.1, so that's way above 0. So there it is. We have X bar driven above 0. And I circled greater than. Well, the reason I did that is because we were going before minus after, and we go, all right, this is our before value, this is our after. And they wanted to see um, where did it go? All right, here in lowering systolic blood pressure. So we're expecting it to the after to be lower than the before. So that's why it's set up like that. All right, plugging in. Well, all we did is plug in our sample mean. All right, our population mean, our expected. 1.663 is our standard deviation, and N is 10. and that's the number of pairs. Notice we actually have 20 measurements, but these are the number of pairs. So N is the number of pairs. Our hypothesis, well, they're claiming it's zero, so we're going to write mu D equals zero. All right. The alternative is that it was greater than zero because we said the before needs to be bigger than the after because this is supposed to be lower. All right. We're expecting this to be lower. All right. So defining our parameter, let mu D equal the true population mean of the differences. And by the way, this is the key phrase right here. You've got to have of the differences. And the reason you have to have this is because this is a paired test in systolic blood pressure. All right, in systolic blood pressure. I'm going to go ahead and run this test. I'm going to do that by going stat, test, t-test. Even though it's paired, we're still just going to go to t-test. We have data. My mean we said was 0. My list is an L3, so blue 3. And we said before had to be greater, so we need greater, and that's what we circled there. And that's what we have for our alternative. All of that needs to be the same. And we calculate. And I get a big old T. I get a T of 28.7077 and a p-value of 3.677. Anytime it's greater than 1, you better look because there's probably an E over there because you can't have probabilities greater than 1. That 10 means I need 9 zeros in front. 1, 2, 3, 4, 5, 6, 7, 8, 9. One less than that number is how many zeros I have to have. Well, anytime you get 4 zeros, you can say, hey, it's approximately 0. All right, so our p-value is approximately 0, and our alpha is 0.01. Well, any value is greater than 0. So whenever our p-value is low, the hose got to go and we reject a null. All right. Well, they told us in the conditions, they said it was random sample of 10, and that was given to us. So we can write random sample of 10 given. We always have to include differences are independent. All right. Don't even need to check it. Just because it's a random sample, differences are independent. That's a given. The sample size is 10, and we always multiply our sample size times 10 and we get 100. Well, 100 is less than 100 million, so N is less than 10% of the population. All right? That's condition number 2. Number 3, well, our sample size, we wanted to do it by normal by central limit theorem, but it's only 10. It's not big enough. But they told us the differences were normal, and that was given. So we can check that off. So all 3 of our conditions are met. Finally, we need to write our conclusion. All right. Please remember, our conclusion is just a restatement of everything we've set up above. Our p-value is less than 0, which is less than our alpha, 0.01. Well, if I were to go back and look at what I said, we said right here, we reject a null. Okay. Our p-value is approximately 0, which is less than our alpha. We reject a null. All of that came from that box right there. Now, we're rejecting, so we have enough evidence. There's sufficient evidence to suggest that the true population mean of the difference, and by the way, there's that phrase, you got to have of the difference in systolic blood pressure of patients. And I want to go back, all right, and remind you that this part right here is just a restatement of our parameter. The true population mean of the difference in systolic blood pressure of patients. That's exactly what we had up here. That mu D equal the true population mean of the difference in systolic blood pressure of patients, exactly the same thing, is greater than 0. Well, let's look at that greater than 0. We've also had that already. We had greater than 0 as our alternative. So please remember the last statement is just restating in words your alternative hypothesis. So this is your alternative hypothesis. All right, I appreciate you watching and I hope that helped. Look forward to seeing you on the next one. Thank you.